students, welcome to Shruti Academy. So let us start with the question number 3 and 4 of chapter 7, integrals of exercise 7.2 for class 12 CBSE NCERT. So we need to integrate the following functions. In the third question, it is being given to us to integrate the function 1 upon x plus x log x dx. So we need to integrate with respect to x, but when viewing this type of function, it becomes very typical how to integrate it. Now the method of substitution is used over here. In the whole exercise, the method of substitution is being used. Okay. So what I will be doing over here, I will be taking x to be common, because x is in the denominator, x is over here also, and in this term also. Okay. So I'll be taking this x to be common. Okay. So it will be integration 1 upon x, and over here will be 1 plus log x, and we need to integrate with respect to x dx. Okay. So we need to integrate it with respect to x. Now we need to substitute 1 plus log x to some variable, so that I can easily get 1 upon x dx to be equal to dt, or to some variable differentiation. Okay. So what I will be doing over here, I'll be taking let 1 plus log x to be equal to t. Okay. Now differentiating with respect to x, both sides. Okay, so differentiation of 1 is always 0, because it is a constant. 1 plus log x will be equal to d over dx of t. So differentiation of 1 is 0 because it is a constant. If we differentiate any of the constant, we get 0. Okay. So here we will be getting 0. Differentiation of log x will be 1 upon x, and over here we are already having dt over dx. Now here comes the trick, that what things should be substituted, what terms should be substituted. So I substituted 1 plus log x to be equal to t, so that I can easily get 1 upon x dx to be equal to dt. So the substitution should be correct. What terms are you substituting? That should be correct in order to get dt in the expression. Okay. So now this dx, I'll be taking that side. So it will become 1 upon x dx to be equal to dt. So in the place of 1 upon x dx, we will be putting dt, and in the place of 1 plus log x, we will be putting t. Now it becomes quite easy to solve the integration. Okay. So let us put down the values. So now it will become 1 upon t dt. So 1 upon x dx is substituted to dt, and 1 upon 1 plus log x is substituted to t. Okay. So this is the method of substitution. So now let us integrate this. This becomes quite easy. 1 upon t, when we integrate it, we will be getting log t, because we need to integrate in terms of t itself. So it will be log t plus c. Okay. So our answer cannot be left in terms of t, because in the question they have asked in terms of x. So I'll be resubstituting the value of t, which was 1 plus log x. So ultimately I'll be getting over here log 1 plus log x, 1 plus log x plus c. Okay, plus c. So this is my answer. Okay, so this is the method of substitution. What I did, I first converted whole expression in terms of t, then I somehow I managed to change dx to be in terms of dt, because I cannot integrate the t when I am having dx. In terms of dx, I cannot integrate t. At that time t becomes constant, so dx should be changed to dt also. So what I did, I assumed 1 plus log x to be t. I differentiated both sides, so I got 1 upon x equals to dt by dx. This dx was here with the division. When it will go to the other side, it becomes with the multiplication. It comes with the multiplication. So 1 upon x dx directly I got, and I substituted over there dt. Okay, and ultimately 1 upon t is log t, and again I have whatever I have assumed the value for 1 plus log x to be t. So I substituted over there, and then ultimately we got a final answer to be log 1 plus log x plus c. Okay, so now let us move ahead towards the question number 4. In the question number 4, it is being given that the expression is sin x sin cos x dx. If we see like this, it becomes very typical to integrate it. How can we integrate such type of questions? Okay, so the only method over here is the method of substitution. Okay, so what we will be doing, we will be assuming cos x to be equal to t, and again differentiating both sides, with respect to t, with respect to x. So d over dx cos x will be equal to d over dx into t. Okay, so cos x can be easily differentiated. We already know the differentiation of cos x is minus sin x. So here it will be minus sin x equal to dt over dx. So this dx is in denominator. When it will go that side, so we'll be getting sin x dx. So we'll be getting sin x dx, and it will be equal to minus dt. If I take this minus sign that side, so I'll be getting sin x dx is equals to minus dt. So in the place of sin x dx, we are going to substitute dt. Okay, so our expression was sin x sin cos x dx. So let us convert this expression in terms of t. So sin x dx, already we have found out this sin x, we will be including sin x dx will be equal to minus dt, and here we are already having sin, and this will become t, because cos x we have assumed it to be t over here. Okay, and over here minus dt we are having. Okay, so now this minus sign will go outside, so now it becomes sin t dt. It becomes sin t dt. Okay, so the integration of sin is minus cos. The differentiation of cos was minus sin x, and the integration of sin x is minus cos x, or sin t, it is minus cos t. So here it will become minus, sin is already there, and again a second minus for the integration of sin t, it will be cos t plus c. Okay, so minus minus becomes here plus. So ultimately our expression and answer is cos t plus c. But we cannot leave our answer in terms of t, because the question which they have asked is in the terms of x. So we'll be resubstituting whatever we have been assuming over here. So it will become cos of cos x plus c. Okay, so it will become over here cos of cos x plus c as our answer. Okay, cos x plus c as our answer. C is the integration constant we need to apply in every question. Okay, so in this manner we need to proceed all the questions of this exercise. Okay, so basically the concept is the substitution. We need to substitute some particular term of the expression such that the other terms which are left, those should be covered in dt. Okay, this is the main concept, and in this manner only the method of substitution works for the integration. So in this exercise, basically all the problems have to be solved with the method of substitution. Okay, so thank you. So please subscribe my channel, please share my videos, and if you have any doubt you can ask me in the comment section. Thank you.